Hello. My name is Gigi Launchbaugh, and hello. My name is Gigi Launchbaugh, and I'm going to be presenting the online Science Cafe today. Since we can't do one in person, this is what we're going to be doing. So I'm coming to you this evening from the Fort Hays State Makerspace in the basement of the Forsyth Library on campus. So, excuse me. So I hope you have we can't have our normal food and drinks like we do it normally at the Science Cafe. So I hope you have a snack or something to drink with yourself there at home. I've got something to drink. We're ready to go. So a few things. I'm supposed to remind everyone, all the students in Dr. Cruz's class, that he needs you to put your name in the comment section. That way he can take attendance. So just remember that. All right, so how many of you know, well, I guess you can't answer me if I ask a question, but I don't know how many of you are aware of the Fort Hays State Makerspace. We're located here on campus in the basement of the Forsyth Library. And the Makerspace was established about 6 years ago by Dr. Adams. And we are open to the entire community. We serve students, faculty, university staff, or any members of the public. So in these times of social distancing, a lot of things aren't working quite like they normally do, thus the virtual Science Cafe, but the Makerspace is open. You'll need to check in at the library front desk if you want to come down here, and we are limiting the number of people who are here at any time, but it's not a problem if you want to come down and see us, and we'll help you with whatever you're working on. So the idea of a makerspace, if you aren't aware of it, is we're a resource to help you make things, make your projects. We have different technology here and then expertise from me and my student workers. We'll help you out with your project however we can. So during our program this evening, I'm going to go through some of the technology that we have that we can help you with. So, what kind of projects do people come to us with here? We do all sorts of different things, from the very simple to very complex. We have people that come down here and they just need to borrow a screwdriver for 10 minutes. And we have people that have been coming here for multiple years working on a long-term project. So they'll come in, work a few hours this day, a few hours the next week, just as they have time available, and we help them with their projects. So, first thing I'm going to do is I am going to show you a few, just a second. Oh. Okay, come on, don't be stupid, computer. Okay, well, I'm going to show you some of the projects that we've helped people with here in the past. I'm going to talk about them and show them to you, just so you can sort of get an idea of what you could do here in the Makerspace. So when people think about the tools that we have available in the Makerspace, one of the first things that comes to mind is our 3D printers. So we currently have 5 3D printers, different models. Some of them are older, some of them are newer. They'll do different capacities. We have a 3D printer that can print multicolors. We have a larger capacity one, and then a couple smaller capacity ones that print very quickly. So all of our printers print in plastic, typically PLA plastic. And I'll go over to the machines now, and you can see some of that. So we're going to get up and walk around here. So I am coming to you from the Makerspace here. So as I walk around, you can sort of get a view of it. This here is our main room. We have a larger outer room and a smaller inner room. And we have equipment in both rooms here. So here in the main room, right when you come in, you can see some of our 3D printers right here behind me. So there's the one, another one, number 3, number 4, and then the 5th one is around the corner in the other room. I'll show that one to you later. So these machines are very versatile. You can make all kinds of things with them, and it's great. You can make something and you can make a modification, you can remake it, customize things. So they print with rolls of plastic like this here. So they come in about 2-pound rolls. And they're not very expensive. You can get them in all kinds of different colors. In fact, I'll go ahead and show you. Going back in here into the back room, we have quite a few different colors of plastic on hand at any given time. Here, this is our cabinet. So you can see different colors. Our machines will use different size plastics. When it comes to 3D printers, typically it's either a 1.75 millimeter or a 2.85 millimeter, and we have some of each. So on these top 2 shelves, this is plastic for our newer machines, and then on this bottom shelf here, this is plastic for our older machines. Most of this is PLA plastic. We do have a little bit of ABS plastic and a little bit of polycarbonate plastic. You can see just some of our colors. We like to keep a wide variety of colors in stock for people. Some transparent. We have some glow in the dark back there. And then just normal colors, orange, red, black, pink, white. This here is wood-filled plastic. So it's actually made with some actual wood in the plastic. It gives a real nice texture, and it kind of smells like burning wood when you print with it. So that's something to be aware of. So we usually keep quite a few different types of plastic in stock at any given time. And if you're wanting to print something in a specific color that we don't have, we're always willing to order in something special for you. So usually it only takes about a week to get some custom plastic in. Over here we can see the larger machine doing a print right now. So this is our largest machine. It's a TAS 4, and it has a capacity of 1 cubic foot. Right now we're doing a print in blue PLA plastic. That's going to be about a 12-hour print. It's about halfway through it right now. So depending on what you're printing, the time can vary quite a bit. Something really small, you could probably print off in just a few minutes, but these larger prints might take a day or so. So what we'll do here, we have software here, and we'll show you how we can load up. So here on the machine you can see some of our software. This is what we use to process a 3D print. So to 3D print something, you need a file in the right format for the machine to read. Typically, you want a .stl format file. If you happen to have a file in a different format, usually it's pretty easy to convert it to that format. So here we can see a couple versions of a STL file. It's a little column capital here. Up here, we can see this is in a CAD program. This is Blender. That's one of the programs we have available here in the Makerspace. There's the file, the three-dimensional object. Then, when we load it in the computer, here, this is the software that will print it. So we need to load our 3D file into the computer. Then we'll set our parameters. It's very similar to like what a printer driver would do with a normal inkjet or laser printer, but there's more different settings. So we're going to change settings that relate to temperature, sizing, support matrix, density. Typically we print these prints with about a 10% internal fill. That's all you need for it to maintain its shape. So there's the file, and then there it is actually printing. So these types of 3D printers that we have here, they all print. There we are. So these 3D printers all print by taking plastic off of their feed roll here, and they melt it. So they'll heat it up to a high temperature. Depending on the type of plastic, depends on the temperature you need to heat it to. So with a PLA plastic like this is, you're going to heat it up to about 200 to 205 Celsius. Right down in there is the heating element. It's electric. It gets really hot, so don't touch it. Here you can see the feeder. Basically, it's just a gear that pulls the plastic in and melts it, and then squeezes it out onto the bed there. So it prints it in layers. You can vary your layers depending on your print quality. Typically, you're going to print about a 0.2 millimeter layer, but that could go down all the way to 0.1 or less for a very high quality print. So what that means is the head of the printer here will move around in the X and Y plane and lay down the plastic onto the bed. So it'll move all the way around, do one layer, and it will move up by the layer thickness. So in this case, it'll move up 0.2 millimeters, then do the next layer, then the next layer, then the next layer. So this particular print here is going to take all night to run. Over here, we can see our multi-material printer. This attachment here allows you to put 4 different colors of plastic in it and do a print with multicolors like that. So I'm going to go over here. I have some of our examples laid out on a table to show you some of what the 3D printer can do. For instance, this is a multicolor 3D print. It printed it in red, white, and black. Here's one in white, black, and yellow. So it can only do 4 colors. You just have to pick 4 colors that we have. You load it into the software and assign colors to different areas of the model, and then it will print them. Here's another example that we did showing a multicolor print. The multicolor printer is a little bit slower than the normal printers, just because it has to print with the 4 different colors. Here we can see an example. This is a partway finished print that was stopped. So if you look at it, you can see the hollowness inside. So this is about the 10% fill like we normally use. That's plenty strong to hold up the object, and it saves material, and it makes it print faster. So, what kind of things might you want to 3D print? We do all kinds of different things here, and it just depends on what you're trying to do. There are thousands and thousands of 3D files available online for free. There are a few you have to pay for, but there are plenty that are free and easy to get. Websites like Thingiverse have a lot available. A lot of museums will have 3D file websites. Metropolitan Museum, British Museum, they have a large part of their collection available as free 3D scans online. So you can do things like this. We can print, a miniature copy of an actual museum artifact. Like this, this is in the British Museum. It's an Egyptian statue, bust of Ramses II. The real one's about 20-25 feet high. So we're able to print a little portable copy here for somebody if they wanted it. Here's another one. This is a museum in Berlin, Assyrian. This is from a museum in Rome, statue, head of Constantine. So all of these are available free. We've printed them off for people doing presentations. We've printed them off for classes where they were studying different things. Then they'd have an actual version of the object they were discussing that they could pass around. Or just people who wanted it just for their own, just something decorative to put in their office. Lots of things you can find. For instance, got a Baby Yoda here. This is 3D printed. So, or here's another replica prop, Indiana Jones, Staff of Ra there. So people doing Halloween costumes or cosplay, we've made bits of costume, bits of props for them this way. What else can we do? So, if you know CAD, you can build a model. You can build it from scratch, or you can start with an existing thing and modify it. So we've got several different objects here that I'm going to show that were created in CAD and we made custom for people. So they were made for different purposes, and just whatever people needed. For instance, this is just a little one. Here's a little tiny clip, and it's just a replacement clip for somebody's window, but they couldn't find it. The window was years old. They don't sell the parts anymore. So we modeled them up this little clip and 3D printed some off for them. Really easy to do. It just probably took 20 minutes to make the model. Took about 10 minutes to print one. And very cheap. We don't charge very much money for our 3D printing. We basically only charge enough to cover our costs. So we're going to charge 15 cents a gram for something like this. And this is like 2 grams. So very cheap. So here are some other examples. So this is a 3D printed clock face. Replacement for an antique clock that was broken. Same thing, we just modeled this up, 3D printed it off. On this one there were actually a couple different versions of it. Printed off a version, made some changes to it till they had exactly what they wanted, and then printed it off again. This also shows one of our different filaments. So this is a metallic filament here. This is metallic copper. That's not one that we always have in stock, but if it's what you want, we can get it ordered in. Here we go. Here's a little maze that was made for a science experiment. So we 3D printed these off custom. Just yesterday, or Friday, I custom made this cookie cutter for someone to help them with a project. Again, really simple to do. Just took about 10-20 minutes to make. And it was, I think it was like 30 cents worth of plastic. So very cheap for them, and they could get exactly what they wanted. Here's a car part that we've been working on. Same thing, custom prototyped this up, printed it out. And we're probably going to do a couple iterations with them to make sure they get exactly what they want. Another thing I have laid out here are some maps. So we have made quite a few three-dimensional terrain maps, topographic maps. So here you can see this, for instance. This is a 3D topographical map of Ellis County, Kansas. You can see Hayes there marked in the middle. There's a really good resource that Iowa State University has out there for free that you can select an area on a map and it will give you the topographical map file in a version that can be printed. And then, for instance, on this one I edited it to add labels. The map I showed you had about a 5-time vertical exaggeration to make it easier to see what's going on. Here's a map of the entire state of Kansas that I made. Topographic map of Kansas. There you can see the slope going from the east to the west. So we've done several large-scale versions of these topographic maps for people. And we did one last summer that we printed in multiple pieces. It was a map of some rangeland here in Ellis County, and it was about 3 feet by 2 feet when the whole thing was done. It was very impressive. Here's another example. This is a topographic map of part of the surface of Mars. So here we can see the Mariner Valley system on Mars. So those topographic maps are great for a variety of things. Classrooms, developing for people. I did one for some people that were going camping, and we 3D printed out the national park where they were going hiking in, so they could have a little 3-dimensional map to take with them when they went hiking. So some other things, we've printed out a lot of D&D characters for people. Again, these are usually pretty cheap, pretty fast. Here's a scientific model. Sierpinski cube, Menger sponge cube. This would have been generated by just a mathematical formula. So you can get your inputs in a bunch of different ways. One thing I'm going to show you now is one of our 3D scanners. So we have 2 different ways that we could 3D scan an object. Here's the scanner. You can see the little ceramic owl there. That's sitting on the laser scanner. And in there's the output on the screen. So we have to scan the object multiple times. It'll output a point cloud that we can convert into a mesh that is editable online, and you can editable with a CAD program, and then you can 3D print it. So there's the original, and there's a 3D printed copy of it. So this is sort of just a little test object, but we've done the same thing with some artifacts for people. So the laser scanner there is good for small objects. You can only do an object about 10 inches tall with it. We also can do it three-dimensional scanning with photogrammetry. That's where you take a bunch of photos of an object and we input it into some software and we can derive a mesh from that. So we've done some of those for people here on campus, for artifacts, and we've even done work on building a model of an entire building with photos taken from a drone. So that's one real nice thing about the photogrammetry, is you're not limited to small hand-sized objects like you are with the laser scanning. Here are a couple examples of a project that we did this summer. So this is a little animal skull. We printed those off for Sternberg Museum as resources for their campers this summer. So this would have been derived from a scan, probably a CAT scan. They got the files online, gave them to me, and I was able to print them for them. So we printed, see what was it? It was about 50 of these different copies of weasel and badger skulls for the campers this summer. And then they could just send the copies, these little plastic copies, off to the students at their home, and they could study them. They didn't have to worry about sending actual artifacts out. Here's another human skull. We've printed out these for several biology classes here on campus, for an evolutionary history class, for a forensics class, all sorts of possibilities with those. So, moving beyond the 3D printing, what are some other things that we can help you with here in the Makerspace? Well, one of the things we have is a vinyl decal cutter. So, here it is. There's our vinyl decal cutter. The machine we have has a capacity to do up to 30-inch wide sheets of vinyl. You can cut them out, make stickers, decals, bumper sticker, sticker for your laptop, all sorts of things like that. Very fast and not very expensive. We have many different colors here. So the vinyl comes on rolls like this. This is a 1 foot wide roll, red. You can see we've got many different colors. Probably have about 50 different colors of vinyl on hand at any time. Some of the bigger ones down there you can see. Those are bigger 2 foot wide rolls. And you can make things like these. We've made a whole bunch of these stickers to give to people as a promotional item for the Makerspace. And these stickers, it's probably about 10 cents each, maybe 5 cents each. Very cheap and very easy to make. All we have to do, I'll show you over here on the computer. We have loaded up the image into the software, and then we just send it to the cutter and cut it. I'm not going to cut it right now because it is loud, so you probably couldn't hear me very well if I did. But it's simple. You can just grab an image. You can edit it, simply just in Word, or more complicated thing that you put together in Photoshop or something. Again, really easy to do. So, some other examples of things that we've cut with vinyl. We've made quite a bit of labeling around the Makerspace. So, all of this signage here, this was cut out on our vinyl cutter. And we've done the same for some other people on campus too. So, what else can we show you? I'm going to, okay. The next thing I'm going to show you here is our laser cutter. So this is a new piece of technology. We have a Dremel Digilab laser here that we got earlier in the spring. There you can see it. There's the machine. Again, very user-friendly and easy here. Just a simple interface. We just have to load in an image. Again, it can be an image that we derive in a video, like a CAD program, a Illustrator type program, or just you can even just take a photograph of something and then we can edit that and cut off of that. So it will cut and etch both. This is not an industrial strength laser, but it will cut simpler things. So we can cut cardboard, we can cut leather, we can cut thin wood, we can cut acrylic plastic, we can cut fabric, paper, and then we can engrave on thicker woods, anodized aluminum, plastic, things like that. I have a few examples. This is an example of what engraving on wood looks like. Basically wood burning. Very easy to do. And you get really nice results. Took about 10 minutes to engrave that. So in this spring, we made a large number of plaques for award ceremonies this way. Here's another plaque. So another example here. This took about 20 minutes to make. Here's an example of something that we've made with the laser cutter, where we're cutting all the way through, not just engraving. So this is a bathymetric map of Lake Superior. It's made by cutting out layers and then stacking them. So for instance, this is Lake Erie here. We stack them up to get the different layers. We derived that data from the same website that we used for 3D printing the topographic maps. In this case, we just converted it into cutting curves instead of to a printable 3D file. So we can help. So if you wanted to make a topographic or bathymetric map, that's another easy thing to do with the laser cutter. We've made plaques. We made a chess set earlier in the year. Engraved this chessboard onto clear acrylic. Many different options. So you can put material in it up to 20 inches by 12 inches. So again, there you can see the laser cutter. And I'm not going to run it right now because it is very loud. That's another piece of equipment that is kind of loud, especially when I'm talking this way. So going around the room, over here is our soldering station. So we have several soldering irons, tools, equipment, if you're wanting to make something or repair something. We have people come in here to repair things fairly often. I've done it myself. Several of my flashlights, tools, things like that I've repaired here. Some electric fans. We've helped people custom build things, Arduino controlled things, some keyboard switching, different things like that. So whether you're building it from scratch or you want to repair something, we can help you with that here with our soldering station equipment. If you don't know how to solder, we can help teach you. We have some little easy kits here that show you how to solder, that we can help walk you through it. Other equipment we have available down here in the Makerspace. We have several sewing machines. Here are sewing machines. If you don't know how to use them, we'll get you going. We'll teach you how to use them, whether you're needing to make something from scratch. We've had people make Halloween costumes, or you need to repair something. We've repaired the inflatable planetarium dome with this equipment. And we've just had people who ripped their pants and needed to sew them up, and we've helped them with that too. Going over here, we can see one of our workbenches. So we have a couple workbenches here with hand tools and power tools that are available to use. So again, we don't have a full-blown wood shop, metal shop here, but for smaller projects, it's really helpful. We can help you out with that. If you're fabricating something or repairing something, we've got a whole bunch of screws, nuts, washers, different components, bearings, things like that, if you might need something like that to repair what you're working on. And wrenches, sockets, drill press, Dremel tools here, engraving, cutting, sanding. These are really handy. Dremel tool is probably the power tool I use the most of anything. Oh, here we go. I'll show you this. This is another example of something that we have done with our laser cutter. We have engraved our name on tools here to mark them. So that's another example of what you could do with the laser cutter. So, one project that we've helped with a lot here in the Makerspace is the high altitude ballooning program. So I have some of that equipment here. So, this is one of our ballooning payloads. We fabricated this here in the Makerspace to hold our equipment going on the balloon launch. Here you can see inside, we have some sensors, recorders to record the data. So working with Dr. Adams, we're going to do several balloon launches later this fall. We've done we did a double balloon launch 2 weeks ago where we launched 2 balloons here from campus, and then they came down south of Victoria. And then we're going to continue to do that working with different students during the rest of the year. This is one of our weather balloons here. This is our radio. And here's another payload for one of the balloons. So we have other videos and pictures of that on the website and other places. So you can look at that later if you're interested in seeing one of our balloon launches. They're pretty nice. It's a helium balloon, about 8 foot in diameter at ground level, lifts about 10-12 pounds. And the balloon will go all the way up about 100,000 feet. Then the balloon will pop when it gets up high like that, comes down with a parachute, and then we'll go retrieve it. Our radio communication box here is how we track it. There's a GPS tracker inside and a radio transmitter inside. The radio transmitter allows the FAA to keep track of it, and it also allows us to track it online. So for instance, last time we We couldn't see where it had come down, but we could see where it was pinpointed on the map with the GPS, and we just walked straight over to it. Easy as can be. So this has been sort of a quick overview of some of our equipment here in the Makerspace. So what I would emphasize is we can help with lots of different projects. We're all of the time, we're helping people with something that we've never been involved with before. So we're learning just like you're learning too. If you don't know if we can help you, just ask us. You can just give me a call down here at the Makerspace, send us an email, and we'll talk to you about your project and what we can do to help you. Whether it would be something with the 3D scanner, the 3D printer, the laser cutter, sewing machines, soldering, or just some kind of general repair or fabrication. We've done all kinds of things like that. For students, we've helped them 3D print or fabricate items for presentations or projects. We've helped them helped them fabricate parts for robots, for display, for art projects. Some of the students here on campus, we've 3D printed components that they used in metal casting for art projects. For teachers, we can 3D print components. We can laser cut components for classroom items, for just display items in your classroom. Examples, for instance, for the one forensics class, we printed off several different examples of bones with different types of injuries on them for the class to study. So, if you're a member of the public, you're certainly welcome to come down here. We've helped quite a few different members of the public with projects. We've helped fabricate some replica parts for automobiles. We have helped people build mock-ups for projects that they were hoping to get going, like for a presentation. And we've helped people fabricate small repair items. We have software down here. So if you're wanting to use any of the equipment, the vinyl cutter, the laser cutter, the 3D printer, any of that, we have software that can help you with that. We have photo editing software, vector-based drawing software, several different CAD programs. For basic people, for basic learners, there's Tinkercad. That's a great, easy first CAD program. We have Blender for some more organic modeling. We've got some AutoCAD licenses here that can be used, and I have a couple versions of Rhino here that people can use. We have Inkscape on all our computers. So even if you're coming in and you don't have any experience with what you're trying to do, we can get you started from the ground up. What I like to say here at the Makerspace is, we're not here to do your project, we're here to help you do your project. And whatever it is, we're here to help you. We've all kinds of different things, from very serious research projects to just 3D printing a fun little cartoon character to set on top of your monitor. We can help you with any of that. We do have a few items we have where we charge for are for materials, and all our charges are very minimal. We just charge enough to cover the cost of the materials. So if you were interested in a particular thing, you just ask us and we could let you know what it would cost to do it. For instance, like when we load up a 3D model in the computer, we can see how much plastic it's going to use, and then we can see how much we're going to charge you for that. So we can see right off, is this going to cost you 50 cents or $5 or $10 or whatever it would be. So you know right off how much money it's going to cost you. Same thing, it will also tell us how long it will take to print there. So the Makerspace is open 8 in the morning till 7 in the evening, Monday, Tuesday, Wednesday, and Thursday, and 8 in the morning to 5 in the evening on Friday, and then we're open Sunday afternoon, 1 to 5. So our hours vary a little bit every semester depending on what the library's hours are and student availability. But either me or one of my student workers will be here during those hours to help you with your project. So I've pretty much given you a walkthrough down here. And again, I encourage you, any of you, if you want to come down here, you're certainly welcome to. With the social distancing rules, you just need to check in at the library front desk, and they'll give you a badge to come on down to us. So we are located again in the basement level of the Forsyth Library, room 062. So you can just come on into the front of the library, go down the stairs, go down the elevator, we're right there. So if anybody has any questions that they want to post in the messages, I'll get back to you on that also. So that's pretty much all I have for you now. Again, just thank you for attending this virtual tour. And I hope to see some of you down here in the Makerspace again in person. And just to remind Dr. Cruz's students again before I leave, that he wants you to put your name in the comments here so he can take attendance. So thanks again. Thanks again for attending our virtual science cafe and our tour of the Fort Hays State Makerspace. So I think I've given you a nice overview of some of the equipment we have here and our capabilities. And yeah, I just hope that we'll see more of you hope that you'll come down here and see us during the year, because we really love to have people come down that we can help them with some kind of project. Thank you again. Have a good evening.